Okay, hello everybody, and thank you for joining our last session now. I will start my presentation. So, thank you for joining again, and not heading for a drink instead. I know this is a very late time for having a webinar, and I'm very glad that you are here. I'm Imre Kiss from Broadcast Solutions Hungary, and I'm a senior project engineer. Today I would like to talk about a very interesting topic, which is actually a combination of two fields, traditional broadcast IT and data engineering. As data is more and more relevant in the media industry, and TV channels have large libraries of digital content, there is a growing need to make use of these collections and sometimes even to reuse existing information in a new system. And the data can include here anything from a simple technical information, for example, the length of a material, to a content metadata, to usage statistics, and to business-related metrics. I will show a solution that Broadcast Solutions Hungary developed to be able to handle data migration and integration tasks in the media industry. So let's jump into the middle. We were approached by MTVA, the national broadcaster of Hungary, with a request to replace their existing media asset management system, which was used for news production, with a more modern and robust one. They used Mission, which was developed by Arvato, now it's called S4M, years ago, and it's now not supported anymore. The choice for the new system was Momentum from Grass Valley. It is a highly flexible and expandable system, which can be tightly integrated to their Cont SQ news system. Naturally, MTVA wanted to use their existing data in their new MEM system as well. That was the point where we hit a wall, as neither the developers of Mission nor Grass Valley could offer a solution to migrate the existing data. So we had to find our own solution to this. We wanted not just to have this job done, but to have an opportunity to make a reusable toolset which can be used in the future as well. Eventually, we created the rapid load framework. But before I show you the details of the project, I would like to highlight some key facts about MTVA, the customer. MTVA is definitely the biggest media organization in Hungary. They are 100% state-owned. They employ more than 2,000 people to produce media content to 5 national television and 3 national radio channels. And has a dedicated news TV channel called M1 and several news and news-like programs on the other channels as well. They broadcast not just in Hungarian, but in English, German, Russian, and Chinese, which was an additional factor in the project. As you can see, failing to deliver a good solution here wasn't an option. After introducing the customer, let me give you a deeper insight of the requirements. MTVA had 330,000 news materials which were to be accessible from the new MEM system with all their corresponding metadata fields. It meant on the top of the technical parameters like file name and audio track count, we had to deliver more than 1.6 million custom metadata entries in a robust and trackable way. Those assets represented more than 48,000 hours of media, which were archived on the Zendata LTO archive. The major source for all this information was an undocumented MS SQL-based system. As we didn't get any help in extracting those pieces of information, we had to reverse engineer the structure on our own. And I will talk about this later. As you can imagine, we were not allowed to impact the daily news production, so we had to keep the old and the new system live for a certain period of time, and then move all the additional data which was created between the first load and the shutdown of the old system. It really made things complex, as we had to handle the changes, like flagging new, modified, and deleted data items, and execute those changes in the new MEM system. We had to do data transformations too. They were not just technical changes, like different character coding and handling of special characters, but we were also asked to make changes in the workflows and how operators handle metadata. So we did business-related transformations as well. It is essential to provide quality checks in these cases to filter and repair inconsistent and corrupted metadata. Another key aspect is logging and documentation. It makes the whole process transparent, and it also reinforces the customer's trust in us and our solution. Let me summarize the key challenges we faced. The source database was completely undocumented, and also the destination system had very limited documentation in terms of how to access its data store. There were inconsistencies in the source metadata fields. We had to support daily live workflow at MTVA. Reverse engineering is often seen as some kind of magic and a field where you need a lot of luck as well. In reality, there are established methodologies to make things happen, and if you choose the right people to work with, it can be a dependable process with a predictable outcome. Speaking about the right people, each of the members of Broadcast Solutions Hungary's team of developers on this project have more than 20 years of experience in the field of data engineering and data systems development. This gave us a solid foundation to deliver what we were expected. But how does this work in reality? How did we do this database discovery? First of all, the information stored in the source system had to be analyzed. There are some tools which can filter irrelevant data from a bunch of tables. We also built custom queries which picked up the interesting bits and pieces. And of course, we had to manually check the results and verify them to what you could see on the GUI of the old system. There were some initial transformations and filtering which were done at this phase. MTVA established the business requirements for the materials they needed, and we applied those requests here. Most likely due to earlier system failures, there were inconsistent data fields too in mission, which we analyzed and corrected. And each and every step was logged and documented here as well. What was our solution and how did it work at MTVA? As I mentioned earlier, we wanted to create a reusable framework which can be integrated in later projects as well. It has several building blocks, as you can see in the picture. Its core is a database which stores the intermediary data and all the technical information and rules and logs. The data validator and the logging module is also closely integrated. To do the transformations, an asset mapper layer was employed. It handled the business transformations and the technical changes, for example, string replacements. The interfacing is done in the metadata loader layer, which can use either API, file, or database connections. If your customer requires, the API and database connection can also point to a cloud source like Azure or AWS. This is not an issue at all. You can see the key technologies in the lower box. All of them are highly flexible, and all the modules they build up can be extended to fit specific needs. You can see that there was a second data source which wasn't highlighted yet. The requirement was set to migrate only those medias that had a high-res copy on the LTO archive. As you can see, that information was also fed into the metadata loader. We exported the details of the stored files and then selected the files which were relevant for migration. The transformation rules then were defined and stored separately for the asset mapper. This gave us the opportunity to integrate late requests from the operators and the engineers. And of course, everything was logged and automatically validated as well. What steps did we have during the project, and how did they connect to each other? First, we extracted the file list from the LTO archive and the raw data from the existing MAM system. Then we loaded them to the migration database. When it was in the intermediary database, we transformed them to comply with the business and technical requirements, and then loaded them to the new MAM system by creating title containers first, to web API calls, and then loaded the metadata to the titles. Also, we verified everything by reading back all the bits and pieces from Momentum. However, this wasn't the final step. As the original proxies were in MP1 format, thus their quality wasn't so great, we restored the high-res files from the archive and we generated the proxies in MP4 format. We also verified the basic file information at this step. As the work had to continue for the news production, we did a two-step data load process. It's called incremental load. And it handled the changes which were done during the LTO file restores. In the end, UAT tests were done and an aggregation of the results were given to the customer before handing the system over. Finally, what are the strengths and the advantages of our approach? First of all, we have a generic framework for data migration and also for data integration, the field of media and broadcasting. As all the parts and every line was written by us, it can be extended and customized to specific requirements. So if you have an upcoming project and you would like to integrate new systems or possibly more systems into your existing one, then we are happy to help. We can also offer a systems discovery service, which means if not all the details of the inner workings of your system is known, we can help you to analyze them and also to document the corresponding workflows. Finally, all the members of our data team has more than 20 years of experience, which gives us a solid foundation to offer you, combined with Broadcast Solutions Hungary's deep knowledge in the media industry, the best solution available for this kind of jobs. Thank you very much for joining us today. I and also my colleagues at Broadcast Solutions really hope that you found the session interesting. You can contact me in email or on phone if you have any questions or upcoming projects inside